Hello guys, welcome back. In this video, I'm going to show you the full solution of exam paper in 2021, November time zone 0, paper 1 of higher level physics. No bullshit, let's go. In question 1, you are given with the information of its mass and its speed. Next, you are going to calculate the fractional uncertainty of its momentum. Therefore, your unknown is delta P over P. And according to the equation P equals mv, then their fractional uncertainty will add up. So you have delta m over m and delta v over v. The values they are just given in the question directly, 1 over 50 and 1 over 25. Then you solve these and you get the answer as 3 over 50. Therefore, it is 0.06. C is the answer. Next, in question 2, you are given with a velocity against time graph, and the gradient of a VD graph is the acceleration. You can see that initially it gives you a very positive gradient, zero gradient, and negative gradient, which means you will have a positive acceleration, zero acceleration, and negative acceleration. A is the answer. Next, question 3. Here we have two boxes connected with a string and moving on a frictionless table. When they are connected with a string, you can consider them as if the same body. So you have a 6 kilogram body under a tension of 12 Newton on a frictionless table. So you can take net force equals ma. The net force is 12 Newton, m is 6 kg, a is unknown. A is 2 meter per second square. This 2 meter per second square acceleration applies on both object X and Y. Then we can focus on object X only. It is a 2 kg object on a frictionless table under a tension going to the right, so that its acceleration is 2 meter per second square. And we can take net force equals ma again. The net force is the tension, m is 2 kilogram, acceleration is 2 meter per second square. So the tension is 4 Newton. The answer is A. Next, in question 4, you are given with a force against displacement graph. In all force against displacement graph, the area in the graph is the work done. Here, it is a triangular graph, so the half base height, it is the work done. Work done, which means energy transfer. Note that it was stationary, so the final energy is the kinetic energy it has. It is half mv squared. The question asks for the speed of the object, therefore we should make v be the subject. By rearranging the equation, you will have f sub 1 s sub 1 divided by m square root. It is the speed of the object. So the answer is B. Question 5. You have a cyclist climbing up a hill, and the final vertical change in height is 100 meters from the starting point to the end point. And the mass of the object is 80 kilogram, which means the gain in GPE should be the mgh with the mass being 80 kilogram times 10 for paper 1 non-count estimation, height is 100. And this is the gain in GPE. What was the energy input provided by the cyclist? The energy input is 200 watt times 500 seconds. So the ratio of these two numbers will be the efficiency, which is 80 times 10 times 100 divided by 20 times 500. 0.8, which is 80%. We choose D. Next one, question 6, is about momentum in an impact motion. Here we have a pellet going towards a block, and the pellet will stuck in the block. So the pellet will become part of the block. Therefore, there must be some friction going between the pellet and block. And this friction will give you certain thermal energy lost. So the total kinetic energy is partially dropped. Next, the total momentum. Total momentum must stay constant if there is no external resultant force acting on the system. Note that the frictional force is going between the block and the pellet. It is an internal force. It's not an external force. In external, there is no resultant force acting on the block and the pellet. So, there is no external resultant force and the total momentum of the system is unchanged. The answer here is C. Next one, question 7. Now you have a ball rolling towards a wall and it's gonna rebound with the same speed but different direction. Note that it was heading to the bottom right, which means there was a horizontal component and there was a vertical component. Let's label them as U for initial velocity in horizontal and U initial velocity in vertical. After bouncing, it will be traveling in vertical components downward and horizontal components to the left. They are V subscript V and V subscript H. And you can see that the vertical components, they are the same. So there's no change in this direction. The only change happening is going in horizontal. Only the horizontal part is changed. And the change was pointing to the right, now is pointing to the left. The change in velocity is pointing to the left. So as the change in momentum is going to the left. And change in momentum is also known as impulse. So the impulse is going to the left. The answer is D. Question 8. Thermal physics. It's a liquid vaporizing into gas under constant temperature. Note that temperature is a measure of the average kinetic energy of a particle. When the temperature is constant, the average kinetic energy of the particles should be constant, so as their speed, which means statement 2 is wrong. It should be constant instead. Then it leaves your answer must be 1 and 3, therefore B. The reason is, when you turn a liquid into a gas, you are pulling the particles further apart. And when they are further apart, the potential energy will therefore be increased. Note that the potential energy is increasing with the distance between the particles. In question 9, we are going to put a metal into some liquid to show their temperature change and thermal energy gain and loss. Note that it is under an assumption of no energy loss to the surrounding, which means whatever thermal energy lost by the metal, whatever thermal energy gained by the liquid. Let's take a look at the thermal energy gained by the liquid. It must be mc delta T. M in this case is 2 big M. C of the liquid, just leave it as C subscript L. Delta T here is 10. So after simplifying is 20 mc sub L. How about the thermal energy lost by the metal? It's mc delta T again, with the mass being big M, C of the metal, and the change in temperature is 80. So after simplifying, you will get AT mc sub m. And these two energy, they must be the same because of conservation of energy. So we can write 20 big M Cl equals to 80 big M C sub m. The required ratio is specific heat capacity of the liquid to that of the metal. So we can rearrange them to make C sub L divided by C sub m. And it is 80 over 20, which is 4. The answer is B. Next one, we have an ideal gas. When we have an ideal gas, we can always begin with PV equals nRT. This is the ideal gas law. Next one, it is under a fixed mass and it's going to expand with a constant pressure. So its volume and temperature, they are varying as shown in the diagram. The gradient of the graph, it's therefore be the rise over run, V over T. According to the equation we are given with, we should have V over T being nR over P. But we do not have such option among A, B, C, or D. What do? We make more substitutions. What else do we do? You can see that in option A to D, there are R and P. But there is no small n, which means we must replace small n with something else. What do we do with small n? Small n is the number of mole. The number of mole could be the number of particles over the Avogadro constant, and also it could be the total mass over the molar mass. Therefore, we have V over T, the required ratio, which is also known as the gradient in this case, being small m, big R over big M, P. And the answer is D. Question 11. You are having a traveling wave, and on this traveling wave, there are 2 points. Their phase difference is pi radian. Pi radian, which means it is half a cycle apart. When it is half cycle apart, also known as separated by half a wavelength. So the answer is B. In question 12, the lights begun with a horizontally polarized light. So if the angle theta is 0, which means the first polarizer is transmission axis is horizontal, all the light can pass through. But when it meets the polarizer Y, the transmission axis is vertical, then there is no light intensity is 0 coming out. In another extreme, if there is a horizontal polarized light in the beginning, but the angle theta is 90 degrees, which means the vertical transmission axis is blocking all the lights. Not to mention there is nothing going to the polarizer Y afterwards. It will be 0. In order to give the maximum energy transfer, it's best to have light passing through the polarizer X as well as the polarizer Y. So what do? We should have these 2 polarizers going as, firstly, the polarizer X is diagonally polarized. So that light is passing through the first polarizer and it is not perpendicular to the second polarizer. Then the light can pass through here. Therefore, the answer is B. Question 13. It is a setup with a double slit experiment. And the equation we use is S equals to D lambda over small d. And what are these symbols referring to? They are referring to the following drawing. S is the fringe separation. Big D is the slit to screen separation, lambda is the wavelength for sure, small d is the slit to slit separation. And in this case, separation of the slits is the unknown, which means small d is your unknown. So you can rearrange your equation, making small d be the subject, then you have big D lambda over small s. Big D is 1.0 meter, lambda is 600 nano. Lastly, small s is the bright fringe to the nearby bright fringe separation. And according to the given diagram, you can see that within 1 centimeter, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 S's. So the S separation should be 1/10 of 1 centimeter, which make it 0.01 meter. And solving these, you will get the answer is 6.0 times 10 to the power of -4 meter, making D be the answer. Question 14 is standing wave. And now we are trying to create a first harmonic standing wave, which means the wave pattern shall go like this one. And then you can see that P is amplitude is greater than that of Q, so the answer, so C is impossible. And node and antinode, they are labeled over here, node, antinode, and node, which means Q is neither a node nor an antinode. Then A and B, they are wrong, leaving the answer D must be correct. Because P took certain time to complete one cycle, and with the same given amount of time, Q can complete one cycle as well. They have the same time period as well as same frequency. Question 15, it's about static electricity. Here we have two sources, positive Q on the left and negative 2Q on the right. According to the question, the electric field strength produced at P by the charge plus Q should be plus E. And this is a radial field. For a radial field, its field strength is actually going as kq over r squared, which means it is electric field strength proportional to the magnitude of charge and inversely proportional to the distances. If this is due to plus q, what about negative 2q? It's going to take 2 times but opposite charge and then twice the distance. So the field strength of plus q and the field strength of negative 2q, they are 1 to 1/2. Let's take a look at their direction. Plus q is creating a field going radially outward, and at the point of P is going to the right. How about negative 2q? It's creating an inwards, which means at the position of P is pointing to the right, and the size of it is half E. So together, they are going to create a total field strength of 3 over 2E going to the right. The answer is C. Question 16 is about the resistivity and resistance of two wires. Let's begin with the same material. Therefore, they have the same resistivity. Rho x and rho y, they are 1 to 1. Next, they have the same length, which means length of x to length of y is 1 to 1. Lastly, their diameter is twice for the x. So the radius of x to the radius of y should be 2 to 1. And based on this information, we can take a look at their cross-sectional area. Assuming that they are circular wire, then the cross-sectional area of x is pi r squared, so as the y pi r squared, which means their cross-sectional area ratio is 4 to 1. Based on this information, let's take a look at the equation. Resistance is the resistivity times L divided by A. And we put it into a ratio of Rx to Ry, so that it is rho x Lx Ax divided by rho y Ly over Ay. And rearrange them, making rho to rho together, L and L together, and A to A together, with their subscript being xy, xy, and yx. Finally, let's substitute all the information we have prepared above. Resistivity ratio is 1 to 1, length ratio is 1 to 1. Lastly, the cross-sectional area ratio should be 1, 2, 4. Take a look at their x, y, and yx order. All right. So the final answer is 1, 2, 4, and we pick A here. Question 17. You have a question about internal resistance. We have 3.0 volts for the EMF and 2.0 ohm for internal resistance, 10 ohm for external resistance, and our target is terminal PD. It's always recommended that to redraw the circuit if there is an internal resistance, which means you can draw it like this one. You have a 3 volt EMF, 2 ohm internal resistance, and then a 10 ohm external resistance. One more step, we can make these two resistors together, combined as one equivalent resistance. It will be 3 volts and 12 ohm. And the currents running through them is not very challenging. Just take it as a V equals IR. V is 3, I is unknown, and I is 12. So I is 1/4, therefore 0.25 ampere. Now the 0.25 ampere is running through every single component inside. This current will pass through the ideal cell, the internal resistance, so as the external resistance. How about the terminal PD? How do we interpret this one? It is just like connecting a voltmeter across the cell. Its reading is the terminal PD. It is the EMF minus the lost volts, and also it is the voltage of the external resistor, I times big R. Either way, we give you the same answer, which is the EMF minus the current times internal resistance, or you can do the current times the external resistance. And both give you 2.5 volts be the answer. The answer is C. Question 18 is about electromagnetism. We should take the right-hand grip rule. The right-hand grip rule could indicate when the current is passing through a straight line. All 4 fingers, they're representing the magnetic fields. And now the 2 wires, they are carrying currents coming out of the page, which means the magnetic field should be going in anti-clockwise for both wires. And the answer is A, cause both magnetic fields around the wires, they are going in anti-clockwise. 19. Circular motions. Here, let's complete the free-body diagram on the object, starting with a downward arrow labeled as mg, and also there is a tension going along the string. The tension shall be resolved into 2 components, with the vertical components being t cos theta, and the horizontal one being t sine theta. This mass is oscillating in a horizontal circle. Therefore, the t cos theta should be balanced with the mg. Then t sine theta is the net force. Because it is the net force, it is also equals to ma. The acceleration will therefore be t sine theta divided by m. Do you have such option on ABCD? Nope. What should we do? We should make substitution with t cos theta and t sine theta together. Let's begin with t sine theta equals to ma and t cos theta equals to mg together and put them as a ratio. Therefore, we have tangent theta on the left and a over g on the right. Then A is equals to the product of g and tangent theta. The answer is D. Question 20. The half-life of the sample is 20 seconds. So at 20 seconds, the nuclide radioactivity should drop by 50%. It is starting from 19 drop to 11 only. From 19 to 11, it dropped by 8 becquerel. Therefore, 8 becquerel is equal to 50% of the initial value. Therefore, the initial value should be 16 becquerel. 16 becquerel is the radioactivity coming from the sample only. Then, the 16 becquerel plus the unknown background radiation would be the reading on your GM detector, which is 19 becquerel according to the question here. The background radiation is 3 becquerel. Answer is C. Question 21. We are going to get the mass defect of a specific nuclide, iron 56. The mass defect is the difference between the mass of all separated nucleons and the combined nucleus. The mass of one single nucleus is capital M. And what is the mass of all the separated nucleons? There are 26 protons and 30 neutrons. Therefore, you should get the mass of proton multiplied by 26 times and the mass of neutron multiplied by 30 times, then minus the capital M. The answer is B. Question 22, Feynman diagram. Let's take a look at the junction on the right. Above this red line, it is after the interaction, below it is before. And we can compare their lepton number. Underneath, its lepton number is +1 because there is one electron. Above, there is a W boson which is 0 in lepton number plus unknown lepton number belongs to X. Therefore, X should be +1. On the left-hand side, we have another junction. So we have another after and before comparison. But this time, we compare their electric charges. After the interaction, there is only one neutron, which is 0e. Before the interaction, we have proton plus 1e, and unknown question mark belongs to W. So W should be -1e. Therefore, we have B. 23. The information of Higgs boson. Higgs boson was predicted based on the existing standard model way before it was experimentally found. So we have predicted it with the standard model, and it was based on the previous theoretical work. And just like every other experiment, you should repeat and repeat and repeat for every single finding to be confirmed. Maybe repeat by a different team of scientists. So the answer is C. Question 24 is about the mass density and energy density of a field. The mass density ρ is the mass over volume, and the energy density U is the ratio of the energy stored divided by the volume. Our target is to make mass be the subject. So let's make M be the subject using the equation on the left. And we can make V being the subject using the equation on the right. Next, we substitute the V into the left-hand side. So it will give M equals to ρ times E over U. Therefore, the correct answer is A. Question 28. We have a simple model of the energy balance in the Earth's surface atmosphere system. As the energy is balanced, which means the total energy going in and total energy going out, they are the same. Let's label the energy going towards the atmosphere be in green. So we have these two arrows being gained by the atmosphere. And the amount of energy gained in this case would be 340 and 390. Then let's take yellow be the energy going out from the atmosphere. We have this one here, and lastly this one. The last one on the right hand side, this is the target of this question. Let's label this one as X. So we have the lost be 100 and then 240, 240, and lastly X. These two amounts of energy, they are the same because of the conservation of energy, and solving these you get X be 150. The answer is B. 26, we have a simple pendulum, which begins with the GPE being 0. GPE being 0, which means we can start making a drawing like this one. You have the pendulum starting at the bottom, climbing up, fall back to equilibrium, to the left hand side, and then back to equilibrium. This is one oscillation. And we are going to study the energy flow in these oscillations. Let's begin with a graph. Vertical being energy, horizontal being time period. It begins with the GPE being 0, and then it's 0 here. When it climbs to the right hand side maximum displacement, it will be very off from the ground, so it has a high value of a GPE, back to equilibrium, to the left maximum, and then back to equilibrium. This is the flow of its GPE. And then let's take a look at the KE. At the center, it's very fast. On the very right, is instantaneously at rest and is about to change its direction of motion. So it will be starting with a very high speed and then instantaneously at rest, high speed, instantaneous rest, and then back to the starting point, which is very fast. To connect these lines, we can see that is a W-shaped line. And how many times does the energy of kinetic and the energy of gravitational potential be the same? Once, twice, 3 times, and 4 times. So there are 4 times the energy being the same. The answer of this question is D. Question 27, it's about a single slit diffraction. Single slit diffraction, which goes in a setup like this one, a monochromatic coherent light is running towards a single slit, and then after passing through the slit, it will start to spread. When it falls onto our screen, we should see a very wide and bright fringe, and sandwiched by some dark fringes. These dark fringes, they are narrower than the central bright fringe. What's coming after the dark fringe is another bright fringe, but the other bright fringe will be less intense and also it will be narrower than the one in the center. When you measure the angle between the central maximum and the first minimum, the angle over here is angle theta. And angle theta is given in your formula sheet. It's theta equals lambda over b. B is the slit width and lambda is wavelength for sure. So let's take a look at this question together. Now the slit width is reduced, which means the B is reduced. So the B is reduced, but the light source is the same as the old time, so the wavelength is unchanged. The theta should be increased as it is inversely proportional to the slit width right now. And the theta be increased, which means the pattern will spread wider. The width of the central maximum should increase. And also because the slit width is narrower, which means there is less light passing through. If there is less light passing through, then the pattern should be dimmer. The answer is B. Question 28, it looks like it's an easy peasy one, but actually there are lots of theory behind. Because this is a video of complete solution, I'm not going to the complete detail of the following explanation. If you want more tutorial, please leave a comment. Maybe next time I'll create a complete teaching of the thin film interference. Here we have 2 reflected lights. One of it is reflected immediately when it hits upon the air and film interface, the red one. This one is undergoing a pi phase change. The other one is first it will refract into the film and then reflect, once again it refracts through the film again. And this one, it has no phase change. Only one ray undergoing the pi phase change. Then you can use the equation provided in your formula sheets, which is for constructive interference. You can take it as 2dn equals to m plus half lambda. M could be 0, 1, 2, or even 3, or even any other integers. Our target is to make the film be as thin as possible, so we are going to pick M be 0. Then it makes the equation be 2dn equals to 0 plus half lambda. Next, we are going to make D be the subject, as D is the thickness of the film. Then D is half lambda divided by 2n. Simplify it, it becomes lambda over 4n. The answer is A. And why we have this equation at first? Why it looks so alike with the equation in topic 4? And what are the derivation of this equation? What happens if we have two rays having pi phase change or none of the rays have any pi phase change? Every detail shall be included in the upcoming complete teaching. If you want one, leave a message in the comment section. Question 29 is about resolving two similar lights using one diffraction grating. And you should take an equation over here, which is R being the resolvance, lambda being the average wavelength of the two lights, then the delta wavelength is the difference in their wavelength, equals to m, which is the order, times the number of slits or number of lines being used in this question. And among 8D, none of them is going to vary the components of the lights, which means everything over the lambda and the difference between wavelengths, they are unchanged. So that this whole ratio is unchanged, the resolving power is unchanged, so as the product of M and N, they are unchanged. If you can increase the N, which means you can reduce the M. Having a lower order, which means the light could be resolved earlier. Maybe you can resolve it closer to the center, which means it's spread less and it's increasing the resolution. Answer of this one is A, because you have the same diffraction grating. The old one was maybe like this one, some light passing through the diffraction grating. The width of the light is over here. And then you can count the number of slits being used is 1, 2, 3. Okay, there are 3 slits or 3 lines being used. What if you increase the width to even wider? Then there will be more light passing through and it will occupy more lines, more slits. This one could be now 1, 2, 3, 4, 5. 5 slits is used. Then the n is increased, meanwhile the order required will be lower. Question 30. We are provided with 3 equipotential lines. These equipotential lines give you a hidden message of the electric field lines directions. They are pointing from the more positive to the less positive direction. And make sure all the field lines that you draw, they should be perpendicular to the equipotential lines. Then you draw a tiny portion of a field line which is perpendicular to the equipotential line, like this one. And then you join them together. So you get the field lines pattern. And you do the same for the rest. Make sure that all the arrows that you drew, they are firstly perpendicular to the equipotential line. Next, they are pointing from the more positive to the less positive direction. This is the E field lines. In an electric field, an electron should experience a force opposite to the field line's direction, which means this is a negative electron and the force acting on it will be opposite to the field. The field is pointing to the right, then the force should be going to the left. The answer is D. 31. You are given with a set of parallel plates. You have their potential value, and also you have the charge of the target particle, and lastly you are trying to get the change in potential energy, which means the work done on the particle. The work done on the particle is the product of the charge times the change in potential. The charge is plus 2.0 microcoulomb And then you have the change in potential being 20 minus 10, final minus initial, which means it's 2.0 times 10 to the power of negative 6 times 10. Then you should get 20 times 10 to the power of negative 6 joules. That is D. Question 32 is about the orbital motion of a satellite. The total energy of an orbital motion should be the GPE adding its KE. The GPE of an orbital motion is given in your formula sheets, which is negative G big M small m over R. And the KE is not given directly. Instead, you can do half m orbital speed square. What is the orbital speed? You can check it up in your formula sheets, which is square root G big M small m over R, and then square for sure. Which means after you put these all together, what you get is something like this one. Negative G big M small m over 2R. This is the total energy of an object in an orbital motion. Now you are going to change its orbit from R to 2R with the same planet in the center, with the same satellites being in motion. The work done is the final energy, which is negative G big M small m over 2 times 2R minus the negative of the initial energy, 2 times R. Then you simplify this one, you will get your final answer as positive G big M small m over 4R. The answer is C. Question 33 is an electromagnetic induction. It begins with a magnet with its north pole approaching to the coil. According to the Lenz's law, the coil should try to induce a north pole at the top so as to repel these incoming magnets. Later on, the magnet would fall through the whole coil and the magnet would be having a south pole leaving the coil. According to the Lenz's law, we should induce a north pole at the bottom, try to retain the falling magnet. So we had a north pole facing up and we will have a north pole facing down. Then the induced EMF should show you a change in polarity. And it changes once. It could be B, it could be C, because it had positive and then negative, positive and then negative. And the difference between B and C is it begins with a zero EMF or it begins with a fairly constant EMF at first. Since the magnet was very far away, so the interaction between the magnet and the coil was extremely weak at first. Then we will pick C. It was almost no interaction when the magnet was so far away. In question 34, we have a full wave rectifier. A full wave rectifier would turn an AC into a DC. Let's take a look at the current passing through the cell. This is current through the cell. It is a sinusoidal path. And we can take the first half as a red line and maybe the second half as a green line. Let's take positive be an upward current like here. Then the current is running through my red line. At this junction, it gotta pick either passing to the left or to the right. The left-hand side one is a backward bias, also known as a reverse bias, so it is impossible. And we will pick the right-hand side one. At this junction, it can either pass through the resistor or the diode at the bottom. And once again, to prevent the reverse bias, it's gonna pass through the resistor and then going to the power source in one loop. Next, let's take a look at the other instant, the green instance. The green instance is going downward at first and it is passing through like here, and it will pick the forward bias over the reverse bias, and from the right to the left through our resistor again, and at the P it will pick the upward and then back to the power supply. So no matter is it the green moment or the red moment, is always from Q to P. And that's how a DC being defined. Currents only pass through in one direction. And that's how we can tell D is wrong. It's exactly opposite. And at one instant, which is at this moment, its current is 0. Therefore, option B is wrong. At certain instant, the current should be 0. And after putting it into a rectifier, the current will look slightly different. The current should always be this positive direction, because no matter is it in the red instant or the green instant, it's always passing through the PQ component from right to left in only one direction. And then it will hit maximum twice in every one oscillation. So the answer is A. In question 35, we have an ideal transformer. Let's take the left-hand side be primary and the right-hand side be secondary. On the primary side, we do know its current. So the I sub P is 2 ampere. And it is a root mean square value, RMS value. On the secondary coil, we do know is RMS voltage. It's given as 50 volts. Next, we know the average power on the secondary coil is 20 watt. And because it is an ideal transformer, so the primary side, its power in average is also 20 watt, given that there is no energy lost. And then the ratio of NP to NS for ideal transformer is equal to their voltage ratio, VP to VS, and it is inversely proportional to their current ratio, IS to IP. What is the voltage on the primary coil? On the primary coil, you can take P equals IV. Of course, you take the average power given by the RMS current and the RMS voltage. Then you can get the RMS voltage on the primary loop should be 10 volts. And similarly, you can get the current in the secondary coil RMS value 0.4. Taking all these information, we can solve the ratio of NP to NS, which is 10 over 50 or 0.4 over 2. Either fraction will give you 1/5 being the ratio. So the answer could be A, could be C. Let's take a look at the ideal transformer. Energy going in and out, they are the same. So the power in the primary coil should be 20 as well. The answer is C. 36, you can see two uncharged capacitors X and Y connected in series. As they're connected in series, which means the H-shaped metal plate is isolated from the surrounding. No charges can cross the H to the surrounding. So no charge can go to the left, no charge can go to the right. It's just like an isolated island in the sea. Therefore, the charge gained by X is equal to the charge lost by Y. Or vice versa, it could be charge gained by Y equal to the charge lost by X. The charge of X and the charge of Y, they are the same. It's a very important information here. Because we will take a look at the capacitance equation. C equals to Q over V, and if you rearrange, you can make Q be the subject, then it's CV. Substitute Q equal to CV into the equation above, you will have C sub X times V sub X equals to C sub Y times V sub Y. Rearrange it, you will get v sub x over v sub y equals to z sub y over z sub x. And according to the question given numbers, it is 2 to 1. This is the answer. V sub x over v sub y. The answer is 2 to 1. C. 37. It is an uncommon graph. It's the stopping potential against the frequency of the lights. Usually, you get a graph like this one. E max equals to HF minus work function, so that you can take y equals to mx plus c. In that case, you can see the y-axis is the kinetic energy of the photoelectron. But right now, it is not kinetic energy. Instead, it is stopping potential. What means stopping potential? It is the external voltage that you apply to the photocell in order to stop the flow of electron. In that sense, you should provide a suitable stopping potential such that you can convert all the kinetic energy of the photoelectron into electric potential energy. So, your work done is the maximum Ke of the electron. And that is the charge times the stopping potential, HF minus work function. Lastly, you make the stopping potential be the subject of the equation. Then you will have H over Q times F equals to work function divided by charge. The charge of the particle is an electron, which means it is E, elementary charge E. Okay, that's it for the derivation, because right now it is the y equals mx plus c required. The m, which is the gradient, is h over e. This is the gradient, rise over run, v2 minus v1 divided by f2 minus f1. This is the gradient. And according to our derivation, the gradient is h over e. D is the answer. Question 38, we have electron passing through a slit, and then afterwards it will spread. And it is spread, which means there will be some horizontal momentum and vertical momentum. We will focus on the vertical components as the question requires. So, in vertical direction, there is some uncertainty in its momentum. The uncertainty of its momentum is conjugate with the uncertainty in position, according to the Heisenberg uncertainty principle. Therefore, we can tell the uncertainty in P is inversely proportional to the uncertainty in position. In this question, the position in y-axis is denoted as d, the width of the slit. Then the answer is B. 39. Here, we are going to have a decay starting from oxygen 14. And the nuclear energy level shows you that to decay from oxygen 14 to nitrogen 14, there must be a beta positive decay. At the same time, there is a neutrino being emitted. This beta positive is also known as a positron or anti-electron. And this positron, together with the neutrino, they share the total energy of 4.1 minus 2.3, which is 1.8 MeV. But the sharing is unknown. It could be 1.8 plus 0, 1.7 plus 0.1, it could be 0.9 plus 0.9. The sharing between positron and neutrino is unknown, but the maximum energy shared by the positron could be 1.8. In that case, then the neutrino is taking 0 MeV. Okay, how about the gamma decay? Gamma decay would not change the atomic energy of the parent nor the daughter nuclei. Therefore, it is a vertical change in this decay. And there is a energy of 2.3 minus 0, which is 2.3 MeV. Then the answer is A. Question 40. We're going to take an estimation of the size of a nucleus using electron diffraction. And here we will take the equation sine theta equals to lambda over d. Lambda is the de Broglie wavelength of the electron and d is the size of the nucleus. In order to give an appreciable result, sine theta should be large or observable value. Then the lambda over d should be in a similar size. One is the size of a nucleus is in the order of 10 to the power of negative 15 meter for d and for lambda here. Then the answer is A. Congratulations, this is the end of the exam. If you have any request, just feel free to leave your message at the comment section below. And I will see you guys next time.